working on, and I would like to welcome Joachim on stage. Joachim Finke, Head of Product Management for Device Interface Connectivity, and he's not only presenting now, and he is not only telling us, explaining us why connectivity is more or less the basis of all industrial transformation, but he's also one of the heads and hearts behind what we have here this week. So two roles now on stage, Joachim, and looking forward for your insights. Thank you.
Yeah, thanks a lot, Kilian. So first of all, before I start, I would like to say I'm really impressed how professional Scheffler is transforming their production plants. Yeah, so it is really, they use all their experience of their plants, of their workers, make use cases out of it, generate values, and afterwards even provide this as a service to other companies. So it's really a great job Matthias Hafner and his team from Scheffler are carrying out, and we from HARTING side, we are really proud and happy to be part of this story. Yeah, what did I derive from the speech of Matthias? So one thing is that digitalization of production plants is nothing you can do within 1 year or within one machine. Yeah, so it's a long-term way to digitalize the complete production parts and afterwards to make use of those things, and this is really very important. Yeah. Second thing I derived is that the major share of value created at Scheffler is not coming from the machine builders. So it's really coming from the operators from the different plants who have access to all the different data, and afterwards think about and create use cases which really make sense for them. Yeah, this is very important because if I am, for example, at machinery customers, typically those companies struggle to think, okay, how can we make our machine more digitalized in a way that our specific small process offers the value to the end customer. Yeah? So this is a different approach. This is important, but at the end of the day, a big part is really coming from the operators in the plant. And the third one is that the major share of value at Scheffler is generated really by the field data. Yeah, the data of the process, of motion controls and all the different sensors, what they detect in the factory, and exactly those are the data which are most important to create those business cases Matthias has just explained. So those are the three things I personally find very important. And now we directly come to the HARTING core topic, connectivity, because what we heard is that the challenge at Scheffler is that exactly those data, the field data, is really complex to get and to analyze, because there are different machines from different vendors who are based on different automation protocols, and Scheffler needs to use some kind of gateways to make the aggregation of those information and data. And this is really a topic which I would say all the different companies in the world they struggle with. Yeah, we have built up a certain structure, different protocols, and now we would like to have the data and figure out that the connectivity between is not that easy to reach. Yeah, this picture shows this, so the automation pyramid in a different view. We all know that in the IT level, the standard Ethernet is really dominating. And we also know that if we would like to have really a long-term, holistic approach, also the OT area must talk the same language, yeah, so the industrial Ethernet. And what we have today is that we have many different protocols. We have traditional field bus systems. We have different Ethernet-based protocols. And all this collecting together and connecting is a challenge. There are approaches to, at least from the protocol, from the software, to combine, or let's say to create with OPC UA one production language which should cover almost everything. I personally think that's exactly the right way. There will always be some other protocols in the market, because why are they existing? They have their specific advantage in specific applications. Yeah, and it will, to my personal opinion, never ever there will be that one communication standards will fit all. But as long as they are all at least Ethernet based, and a major share even is talking OPC UA, we are really a big step forward to make that connectivity and connection better. So means the trend clearly in the OT area is going to the industrial Ethernet and to connect all those end devices we can see here on the screen from sensors, from actuators, drives to the industrial Ethernet world. So if we now have a look at Scheffler, yeah, it's one customer. We need to say, Matthias, a very big customer, but it's just one customer. And we learned from Matthias that all in all global production plants at Scheffler, 25,000 machines are in use. Yeah, 25,000 machines. They were installed maybe 10 years ago, 5 years ago, maybe even 20 years ago. Yeah, so there was a very, very big part of brownfield in their production plants. But all in all, 25,000 machines. And those machines, they will run during the next couple of years and years and years because, of course, we would like to digitalize and connect them, but nobody would scrap a machine which costs maybe 1 million or 1.5 million just because the connectivity is not in a way it should like to be. We solve this by, for example, gateways. Yeah? And this is fully reasonable, and this will also continue during the next couple of years. But to underline the importance of connectivity, and now I really switch to the physical connectivity, we see how important the connectivity part is. If we talk about 25,000 machines, and we, let's say, calculate that maybe each machine has 40 sensors. Yeah, so this is, I would say, a standard value. There are machines who have much more sensors than 40. But if we calculate with 40 sensors per machine, then we talk about, in the long term, more than 1 million sensors and actuators just in the Scheffler plants, which have to be connected to the digital world. Yeah, so it's really, it's a very huge amount, and this is why the physical way of connecting those machines really has a huge impact. If we talk about the physical connection, we directly also, and look into the future, we directly also talk about, will it be wired or will it be wireless? Yeah, that's the everlasting question during the last couple of years. We all know that today, if we refer to factory automation, the copper-based cabling is for sure dominating due to very good reasons. But of course, there are new technologies, wireless technologies, which might change this and could switch to a different situation in the future. If we have a look on our private life and try to answer this question, I would say the question is answered. So in our private life, wireless is the dominating physical termination. No matter if we install our printer and would like to connect it to the network, no matter if we use our mouse at the notebook, if we use headsets, if we note watches or iPads, I would say most of them are wireless today, and those who are still wired today, they will switch during the next couple of years. So means if we look in our private life, then this question is fully answered. If I now look into the studio, the equipment we use here, there was one nice talk I had on yesterday, because I connected my notebook here and tried to start my presentation, and then one of the IT guys behind us, Dominic Damm, he came and said, Joachim, we need to wire this with a LAN. And I said, Dominic, why? I have connection. It's a company place here. And he said, yes, you're right. But if it really counts, like on tomorrow, so today, the webinar, I would feel more safe if it's wired, because there always is a slight risk of that wireless technology. And I said, oh, that's very interesting. That's very interesting. And it's something which in the industry is, of course, mandatory. Yeah, so when it counts in the industry and production plants, it always counts. There is not, it doesn't matter. Yeah, so means that the question of wired or wireless is not answered in the industry so far. If we have a look on the existing technologies which we have for wired, then we all know we have the fast Ethernet technology with 2 pairs to connect devices up to 100 Mbit and 100 meters. And we have for more high performance applications the gigabit Ethernet, where we have 4 pairs, also here 100 meters, where we could use to connect, for example, vision cameras. So those who need maybe 1 gigabit or even higher gigabit data. So that's the situation we have, and which is mainly deployed in the different factories. If we have a look on the wireless technologies, and I cannot now sum up all the different technologies, we need to focus. We see here 4G. 4G is a technology which was not, when it was standardized, it was not standardized according to industrial requirements. Yeah? So it was standardized for the consumer needs and private need and enterprise need, but it was not really designed for industrial usage. Then we have Wi-Fi, also a technology which was not designed for industrial applications. And those are used here and there. We come back to this later on. But we all know that the major share in a production hall is really based on wired technologies. Then we have fiber optic as well. If we would like to cover distances for more than 100 meters, or if the MC pollution is a topic, so fiber optic is a special topic, I would say, but of course it's existing. So let's now, and this is important for today, have a look on new technologies. So wireless and wired, of course, further develop. And especially for wireless, we all know that 5G industrial is a very huge topic. And 5G industrial is a topic which was directly at the beginning standardized by keeping the industrial requirements in mind. And the second one, on the copper-based technologies, we have single-pair Ethernet. So it's also a new physical layer, a one-pair copper-wired Ethernet transmission. And those, I would say, are very promising. Yeah, wherever you go in the industry areas, companies are screening those technologies and think about to implement them into their future architecture. So let's now have a more closer look on the 5G. So what is the importance, or let's say the advantage between 4G and 5G? One very important one is that the service and the availability. Yeah, so with 5G for the first time, it is possible now to really realize non-public networks. For example, for a big production plant, yeah, to have your specific personal company-owned network. This is very important because then you could, by yourself, make sure that the availability of the network is given. Second one is the latency and the cycle times. And also here, 5G was created in a way that due to the speed, industrial requirements with regards to latency and cycle times, they are given. And they are even given for applications, high-performance applications like motion control with servo drives. Yeah, also a big step. By this, we are able to reach real-time requirements with 5G. Yeah, also something not possible with 4G and before. And last but not least, the number of network participants, I would say, is almost unlimited. Yeah, I think there is a certain quantity, I think 1 million within whatever of square meters, but with regards to factory automation, we can say it's nearly unlimited. So really 5G has incredible advantages which were not existing for other wireless technologies in the past. What is the disadvantage we need to consider? One is that those frequency bands to install and create private, non-public networks, they are, I would say, even a government issue. Yeah? So you need to reserve frequency bands, and this is done in each country individually. Maybe there are some countries who merge this, but if you are a machine builder, and if you would like to deploy your machines in any country in the world, and not say, oh, but it's not valid for South Africa and whatever, you need to make sure that you need to consider this, yeah? So the frequency bands, if we talk about non-public networks, is an issue, is a very important issue which is not 100% solved, and it will be a long-term issue. Second one is EMC pollution. So we all know that copper-based cabling, we could shield and we could protect them from ESC pollution. And this is simply a part of the physical connection of wireless. It's not possible to protect them fully from EMC pollution. Yeah? And this could affect the availability and the reliability of the network. And the last one is that, yeah, data transmission is possible, but anyway, you need to charge or power supply your devices. In our private life, I have shown before, all those devices we charge. Maybe once a day, maybe once a week, depends on our usage. which is okay for private use, but we all know that manually every week or even every month or every half a year to charge certain devices is not really suitable for industrial applications. So also a very, very important point to consider. And this means if we talk about applications, so 5G for sure will be deployed in the future. It will bring very huge effects also in industrial applications. And I'm personally really a fan of 5G. And it will further be used, for example, for long-distance applications. It will, especially in mobile applications, so HGVs, mobile robots, and all those things who move, who you can't cable, 5G will really bring a big step forward. Then we have production plans. So there are some production plans which are tailored to be reorganized frequently, yeah, to reorganize the machines and the parts flow in the production. And especially here, hardwired is no option. Plugging those machines is an option. But of course, wireless, at least data communication, would really bring a very significant effect here. So also here, in dedicated production plans, really a very big advantage. And also here, then the last one, augmented reality, for sure is an issue. We will see also later on an example, and those need really high bandwidth and the power 5G generates. Okay, this to 5G. Let's now come shortly to single-pair Ethernet. Just in easy words, what is single-pair Ethernet? Single-pair Ethernet is the Ethernet transmission copper wired by just one single twisted pair. So means it has a big advantage that we could save different copper wires, which we today need for fast and gigabit Ethernet. Yeah, and this has many different advantages. So one advantage, for example, is that the weight will be decreased by 30%, and further advantages. So very quickly to the performance of single-pair Ethernet. Single-pair Ethernet is not up to 20, 30, 40, or 50G. Single-pair Ethernet is coming from the automotive market because there the companies, they searched for a technology which is able to connect devices in a high speed, but on a cheap way, and especially sustainable way. And that's what single-pair Ethernet was designed for, and now it finds its way into the industrial applications. The performance goes from 10 Mbit even up to 10 gigabit, and of course we have all the different standards in between from 100 meters and 1 gigabit. But just as a quick view on the advantages of this technology, one is with SPE, it's possible for the first time now really to go over the 100-meter border of copper-wired termination for Ethernet. We have 30% less weight, which is exactly or especially for transportation or mobile applications very important, where kilometers of cabling are installed for Ethernet. The cable is much smaller, and the diameter is smaller, and the bending radius is much smaller, which really is a huge effect in robotic applications, where the cable needs to go from the robot foot through the axis to the flange, where the tools are. So also here, nice advantage. And of course, we are able, with this technology, if you put one cable to it, to power supply the device, and at the same time realize the data communication. Yeah, so means if you go there with a cable, no matter if it's hybrid or power over single-pair Ethernet, you just need to connect them with one cable. And very important one, so cost efficiency and sustainability, especially sustainability. I have the feeling that during the last years, of course, everybody would like to be sustainable, but during the last 1, 2, 3 years, I really feel it in a very concrete and serious way of our customers, that it's not just a buzzword, sustainability, but they really require HARTING to show what we are able to deliver. And also here, this technology, we have heard about the 1 million sensors and actuators only at Scheffler. And if we now think about all the different companies globally and think about the copper we could save, we understand that this really is a sustainable solution. One topic to be solved is, of course, the auto negotiation. Maybe it's too technically for today. It means that devices who are speaking different speeds, 10 Mbit or 1 gigabit, that they directly identify this and could communicate to each other. But I would say this is something which is on the way to be solved, and it should not be an issue for today. But all in all, this technology is perfectly suited to connect the devices. Matthias has explained in before, the devices in the field level to the Ethernet network. All right, so to sum it up, the field level connectivity plays a very major role in the transformation of digital production plans. Ethernet-based communication will simplify the network and will simplify for sure the access of the field data, very important. New data transmission technologies are key for this because the technologies which we have today, they are not really suitable they are not the best way to go on during the next 10, 20 or 30 years. 5G will not replace wired connectivity, but it will enable especially new applications and really bring a huge step forward and complete the overall network. Single pair Ethernet will not replace the fast and gigabit technology where it's placed today, but it will be the lever to connect field devices. And very important, the implementation of those two technologies, it has already been started. There are not only lighthouse projects, they are even now in first projects at customer side. And if you would like to learn more about single pair Ethernet, during this week on Thursday, we have a special dedicated presentation with regards to SPE. All right, so that was the basic outline of my presentation.